will be input into the, and for the next prediction is called the sampling. Now, sampling strategy via greedy search can be of three types. It can be of greedy search, it can be of random sampling, or it can be probability distribution using the different temperatures. So it can be of greedy search. You can see the simplest one, the most common method used in the past. So you have a the, and then the next one is searching for the cat, most highest probability of the cat, then maybe most highest probability of the is, then you have a is home. So it's the most commonly used greedy search method. The most simple form of sampling is greedy search. Now at each point it will pick up the most likely next word based on the probability. For example, the cat is home. However, this method has few drawbacks. These have some little bit drawbacks. What they are drawbacks? Let us learn. Now, first, it will generate the only one sample. First of all, it will generate only one word or one character. Yeah, right now, here you have an example of word. It will generate one character or one word. Only it can see for the next word. If you would like to have more samples to choose from, then it's not easy for them. Further, it can not look ahead. It cannot look, can look for cat only. It may not be possible to look for is or home. So it could be, for example, have created the cat instead of the cat is home. So it just create the cat, again it create the cat, because the has maximum probability than is. So it can be repetitive words than is, because the after the cat had the highest probability. So there may be a repetition of text instead of the sequence of word. So when you use greedy search, it will, when you type the cat, it will return you the cat again, and then it will be is. So two times the cat, and then maybe you have another word, because it uses the next highest probability. But it couldn't see the cat is home was better than anything. It could create the cat. So the cat, because the has a maximum probability, so it cannot see the next is home has the max, will be the most preferred word compared the. So this is the drawback of using a greedy search method. Now, uh, in random search, the next one is a random search sampling strategy. Now, random search works by selecting the next word with the probability of each word token from the output of the model. So it will make a conditional probability or based on the first word, the next one. For example, the word the has probably 0.8, so that 8 out of 10 times the next word the. So you have 8 times more than the next word. 2 out of 10 times it will generate another word, whatever it is, maybe next cat is our home. Many advantages is that the results are very diverse. However, often the results too diverse, they look too random. Sometimes the issue of this one is sometimes very random words selected. To fix this randomness, we increase the probability of the most probable words and decrease the probability of the less probable ones using the temperature. Means you are applying some weights to the words according to the occurrences. If is usually is occurs most of the times, the occur most of the time, but cat and home, these may occur less number of times. So by having such kind of words which can have large major occurrences, may have some temperature, or you can say they may have some value or some weight as compared to the rest of the birds. The higher the temperature, the more diverse result it can give, the vice versa. So similarly, you are not supposed to take the maximum. If you give large weights to the and is class is words, then they will appear repeatedly. But if you make them very low, then again rest of the words will appear, cat and home will appear repetitively. So there must be something in between. There must be something in average, we should be in between. See, if I apply the temperature 0.01, the probability of sampling means that the same words can be repeated most of the times. So if temperature is 2, multiple words you can see are predicting. If you increase 0.4, little bit more words can be predicted. 0.6, as you increase one, this is highly random words. So this is easily not as understandable, and this is highly repetitive words of same kind. So keep the word. So usually preferred we have 0.5, 0.4, or 0.6. So this is the best way to assign the weights, which will be in between the repetition and the random chosen of different words which have less meaning to the human. So this is a kind of temperature you can see. This is just for explanation. The routine has been made to assign the temperature for reweighting the distribution. So distribution of words with some weight is can be made for this one instead of having simple one. So this is a code. You can go through the code from the book. The first thing that you need is lot of the text data that you can use the learned language. So let me just show the example first. If I have these weights, what is happening? If I will explain this code later. Let me just go through for the output of this code. Suppose this is output of a code. You have input the word. If I say, you have input the word. If I say, see here, here is the use of random new. Now this word is used, new faculty and the duplication read, jubilation reacted its climax when can't. Now this is some text from a story. You can see here from now it has when you type these words, then the next prediction, what will be the next prediction? You can see if your temperature is 0.2. See, the words are highly, you can say, repetitive words, which are when they see spiritual, surely, such as men, as this. So many words are repetitive, which are meaningless. If your temperature is 0, as you increase 0.5, you can see the words are a little bit high, better in meaning and less repetition. The words are selected near to the human language. As it's 1, then highly, just the words are there, but they're highly difficult to understand. When you read this text, then you understand what will happen. And depends on the epoch 20. When you increase the epoch, the accuracy is much better than again, because number of epochs makes a model betterly trained. So at 0.5, you can see little bit near to the human language for prediction of the same text. For 20 epoch, you have this output. So this is a little bit output that I can show you here when you use the temperature for random searching for sampling the data. So this is a method we use usually. So let me just go through the code now. See here, little bit code about the code, so that you will, if you are interested, you can implement this one. Otherwise, you just understand the concept of having. Now this is on applying the temperature, and then next one you and implement the character level LSTM text generation. When you apply character level, then this is the discussion for the character level. The first thing you need lots of text data that you can use to learn a language model. How you train the model? You need a lots of data, maybe taken from anywhere, to train the data for learning the words one after the other, learning the characters one after the other. And now you can use any sufficient large text file or set of text files taken from anywhere. You're supposed to take a text file, contains lots of text, lots of words, to train your model for the character prediction. In this example, you will use some of the writing of Nietzsche and the late 19th century German philosopher translated in English. You will use some of the writings. You can use these writings for this one. They are highly preferred for training the model. So this is a suggestion for Nietzsche writings, where they may be author of lots of things that will written philosophically. You can have lots of text for training the model. The language model you will learn will thus be especially a model of Nietzsche's writing style. So you can keep this one. Suppose if you are training a model on any novel, so it will be it will train the pattern of that novel. Suppose you have a novel and you train your model on the words of a novel, then it will be highly inclined to such kind of language. So it just learns the pattern of an author, because each human have different ways to different vocabularies and different ways to use the words. So the model will train accordingly whatever you have given the word. So you need lots of text to train the model to predict all kinds of patterns. So this is the case. You need lots of the text for training purpose for character prediction. Now implementing character level instrument, how you can implement for this one? The first thing you need is to lots of, now I've just explained this text already. Now language model learn, now you can use sufficient large text files, and then philosopher, you can have this one. This is the, you can see, you can have example of having text from, you can download the text from Keras. It is already there to train your model, so that you can have a just experience of having training of the model. And then you have similarly maximum length of the characters is step 3, new sequence of 3 characters. It will predict 3 characters in advance for you, so 3 outputs. Then sentence, you are supposed to store sentence here. The next character will be stored here. You are supposed to have hold on the targets for makeup characters. You are supposed to hold on the output of your data, whatever the model you have. And then you have unique characters in the corpus. You can remove the repetitive characters and can have a unique characters so that you can be predicted or can be trained to the model. So this code is well explanatory. I hope class you can go through this code and will be able to vectorize your sequence. This is actually not vectorizing a sequence. Whatever the data you have, you must vectorize it by having any kind of technique, maybe character wise or maybe word wise or any one hot coded, whatever you use. Usually we use the word embeddings because word embeddings have ability to make the correlation between the words. So single LSTM layer, you can create a single LSTM layer by create the model and then train. This is a model creation. This is model training. You can use the train the model using that words. And then training the model on training the language. Let me just see the text snips. You can generate new text by doing the following and draw from the model a probability distribution from the text character given the generated text available so far. Reweight the distribution, certain temperatures, you can apply the certain temperatures as I shown the output already. Sample the text random according to reweighting distribution. So use your random according to this weighted distribution. Add a new character at the end of the available text. Whenever you add the text, it will be added at the end and the next prediction will be made for the 3 characters only. So this is a very simplest example. It may be very complex code to predict the characters as well as the words. So for simplicity is a very simple example for you to predict the next 3 words by using a fixed data which is there based on any author. So you can have prediction according to this one. So this is the output, and then you can go through this example and see the output, the way it represents the data once you given few words and then return you the next. Now, as you can see, a low temperature value results in extremely repetitive and predictable text, but the text is predictable, but you can understand the text, but it's repetitive. I am 2 times. But the local structure is highly realistic. Local structure may be same, realistic, but not necessarily there may be a specific human like language. They're highly repetitive. Highly now in particular, all words being local pattern and characters are real English words with higher temperatures. The generated text becomes more interesting, surprising, even creative. Sometimes you need the creative words which you do not use in your text, but it will predict for you. It's sometimes even completely new words that sound somewhat plausible. Sometimes you need to use the alternative better words. It looks very better in sense with a high temperature. The local structure starts. So if you use high temperature, the prediction will be very accurate, but it is not like a human sequence. So for it may be less repetitive. It will generate best words, but they are not in a sequence that human prefers. Without a doubt, 0.5 is the most interesting temperature for the text generation in this specific setup. Always experiments with multiple sample strategies, a clever balance between learning structure and random, because they have trade-off. If you improve the structure, then you are supposed then you are supposed to increase the weights, and maybe the predictivity will not be that much you call plausible. It will not be any good predictions, but meaningful predictions. So keep the temperature in between so that you maintain the sequence of the words, and then what you call the structure of the sentence will be maintained. Maybe the less what you call it accurate words will be there. So this is the possible way you can train the model. So class, is there any confusion? You can ask this one, and then let me just wind up this subject. I hope it is clear. It's very easy. You can go through this is, you can say YouTube a little bit generative model context. You can go through this video. I'm not here to just explain this one. You can go through this one and you will learn the gains with a little bit about the gains. However, I have explained the gains. They are used for predicting the mimicking the human like words that cannot be uttered by anyone. So you can go through the gains as well. Previously I have explained a little bit about the gains. So I hope it is a little bit clear about the text and the deep learning. I have made my efforts, lot of efforts to let you explain each and everything
Recording
more
stopped.
clearly. So is there any question, class? You can ask right now. Otherwise, I think I got a query from your side to explain the variance in bias, or what is it, what is the, uh, what you call it, underfitting and overfitting. So let me just give a one slide on this one, because I have already explained, but for further explanation, I have made this little bit 4 or 5 slides for this topic. There is no confusion in GRNs, then I will proceed for this topic. Very little topic just to explain you how you can handle these issues using the model, because we have finished the topic. This is very uh, small topic, but very important.
No query, sir.
Okay, so let me just start this. You know already about this one, and you learned this topic previously in many in your various subjects. But let me just revise it, and then you will be able to understand how you can handle this one. Now, what is bias? Before understanding the overfitting and underfitting, you must learn the bias and the variance. Simply, I can say if your model is very least trained, then it shows that it can predict, what you call it, it can predict it can show you the wrong results while training and on testing both. The bias is actually the error when your model shows a high error on training model as well as on testing model. So highly unpredictable results. So such kind of results usually found when your model is trained on very small amount of data, very less data. It is trained not for the required time, so that learn features, complete features from the data. So you can face the bias. So when the model is overtrained, then it will be a variance. You such that it will show, and this is named as a variance. It will tries to fit on all kinds of points. When your model tries to fit, very shows very high accuracy on training data, but very low accuracy on your testing data. So this is called a variance problem. So error between average model prediction and growth truth. This is the average. You can see what is the average model training and then growth truth. The bias of the estimate function tells you as the capacity of the underlying model to the predicted value, how this model is less predicted to the training data as well. Now, variance is nothing, just how much your output is far from the target. So it is a calculation based on how far. This is how wrong, how away from the average, and this is how far from the average. The average availability in the model prediction given for the data set. The variance of the estimated functions tells us how much the function can adjust to the change in the data set. So if you change the data set, it will show high error. If you keep the data set static, it will give you good results. Or here, there's no concern of change data. If the data is same, even can show the highest errors. So this is possible. So if the data is same, it shows the highest error. Here, if you change the data, it will show highest error. Otherwise, it will be perfect. So high bias means oversimplified model. Means model is highly simple, so it cannot understand anything. Then it shows it is usually underfit. Okay, high errors, underfit, high error on both tests and training data. It shows both high errors on both of data. And then where high variance means over complex. Your model is highly complex. Maybe you need 8 layers and you created 25 layers. So your model is highly complex. It shows an overfitting error. Now lower error on training data and high on test data. See, it most likely to fit on training, highly fit on the training data. But when you give the test data, it shows you the high error. So it starts modeling the noise into it. It really learns the noise as well. Outliers, they can try to learn the outliers, usually like this. So when any model try to learn the outliers, then definitely it will be overfitted. Now, this is a simple explanation how you can choose the model and then what this mean. If you are suppose I keep here the low variance, high variance, low variance, and then you have low variance and high variance. If I talk about the target is to have, now this is the target. The center circuit is nothing your target. Your data, your prediction should be here, but this is the ideal situation. Now this is, you can say that when you have low bias and low variance, this will be the ideal situation. Usually we do not find, but we can be nearby these two, which can be possible, which can nearby the low bias and then we can nearby the low variance. But usually they have trade-off. If you increase the bias, then you are decreasing the variance. See, if you are increasing the bias, you are decreasing the variance. So there must be something in between these two, variance and bias. You need something in between that is over here. You can see this is the minimum error. You have to compromise somewhere for the bias, and then the most and the, see, this is not the minimum. Minimum is this one. For bias minimum is you have compromised this one. Maybe this is 0.1, this is 0.2. So you have compromised the bias. Similarly, you are compromising the variance, and then you will be here. This is the midpoint where you can have better performance. That is just right. If you are here, you are underfitted, means your model is underfitted. You have low variance, high variance, okay, low bias. You have very low bias. So low bias means you have better, initially shows better results on shows high better results on what you call it, data, and then target is different from this. So you can see here, class, if you have low bias, low bias and low variance, your data is near to the target. Near to the target means both have training and testing as better performance. But if you're low variance and high bias, your data is highly far from, and then maybe not predicted with the one label. You can say like this. This is a high variance and then low bias. You can see here you have the data can be highly and undeterministic. It can be any label to this data and then far from the target. You can see this is opposite to this one. On the left side and the other side, you can have a scattered non-deterministic, show non-deterministic. This can be deterministic. This can be deterministic. This is non-deterministic. This is non-deterministic, means you cannot predict what will be the output. And non-deterministic. This can be deterministic, but wrong. Determinism you can predict will go negative, wrong results, but not that meet to the target. See, this is meet to the target, but scattered, means it's unpredictable results. You can say this is highly unpredictable if your bias is low and bias variance is low. So bias variance trade-off: increase the bias, reduces the variance, and vice versa. Now error, you must calculate the error here. You minimum error can be calculated by having this one, bias square plus variance and irreducible error. Some errors which are cannot be reduced. This error cannot be reduced. Some errors which cannot be reduced should be there. The best model is where the model is reduced. The best model is where the error is reduced. So you are supposed to have minimum error possible, and you cannot have a uh, where the error is reduced. This error is less. Instead of just bias less or variance is less. So then compute between the bias and so something in between these two. So this is the best example. If you're overfitting, means your model is trying to fit all points for the training data. When you give the testing data, it will show high error. If your model is like this, it does not train the data. It is very, you can say, trained not according to the data. So this is very lessly trained, very poorly trained model. So this is underfitting. So it can show the poor results on training as well as on testing. While here you can see it can give you not the best results on training or best results on testing, but it will give you average results, just right. It has some wrong predictions, some good predictions. So you cannot assume. That's why I say if your accuracy is 95%, you can say the problem is solved. That's why usually I use these words. You cannot say the accuracy can be 100%. If the accuracy is 100%, there's something wrong with the model. So you assume that accuracy is nearby the 100, not 95, 94, 92, good accuracy, but best accuracy assumes the best accuracy for the model, because we cannot model perfect. This is 100% for the training data. It's not possible for testing data. So this is the case. You are supposed to use these two features. How you can avoid this one, class? Last one, use, these are the remedies that you can apply. Always keep your model simple. Your model should be the simplest one. It's better to have a simplest model. And then early stopping, use the early stopping to avoid the overfitting, because this is early stopping. Actually, you are stopping here, you are early stopping. You cannot go for here or here. You are supposed to go early stopping. Then data augmentation, you know about this one. Now there are ways to augment the data. You can have geometric transform. You can have I already told you, you can have what you call it, frequency domain transforms. You can have generative adversarial networks. You can augment the data by having so many ways. So use the regularization. I already used L1 and L2. You can use regularization methods to keep your values between some specific ranges. Use the dropouts, some, because some neurons can generate same kind of data, which makes difficult for the model to predict the label properly. So by using the random dropout neurons, your performance may be according to the targets. So it can reduce the errors. Use the label smoothing. Label smoothing is nothing, just you cannot put ones and zero label. It's better to avoid use 0 1 label. Yes, yes, by yes and by no. This is a hard kind of label. Whenever you train the model, if you think that your model is overfitted, use the label smoothing options. It's available in Python. Just go through and search what is label smoothing. Label smoothing, instead of keeping yes as 1, keep it 0.9. Instead of having 0 instead of and 0.1 for yes and 0.1 for no. So you can have, if you want to predict yes, so yes has 2 labels, probability maybe 0 1. So you cannot keep the probability 0 1. You can keep the probability 0.1 and 0.9. In such a way you predict it's a yes. For no, similarly, you can have predictably 0.9 for no and 0.1 for yes. So it's not rigid 0 and 1 values. So if you keep the values rigid, the model cannot be trained properly. It faces very difficult to manage such kind of rigid labels. So it will predict you a probability like the similar one. So you can keep the label smoothing as well. If this data is small, use pre-trained models. Always use pre-trained. If your data is small, your model can go overfitting or underfitting. It's a common problem. So use the pre-trained model, or use some layers pre-trained and some layers which are trained from scratch. Already shown the example in previous classes. You can have different ways to go for this one. So you can see C class. This is the things they can apply. They make the data class based balance. This is also very helpful when you are using the data. Keep your data class wise balance using oversampling, using undersampling, or any kind of method. You can use it while splitting the data. I have explained all these in detail in my previous classes. So you can go through. These are the remedies that you can use while avoiding the overfitting and underfitting, or you can say controlling the bias on variance trade-off. So I hope this clear class. Any query class? If there's any query, you can ask. This is a very common topic. Maybe you know about this one. So if any query, you can ask right now.
Yes, sir.
Any query class? Now a little bit about the paper.
No, sir.
If it is, I think you have already concept for this one, so it will be helpful. How you can avoid, if you have projects, you can avoid this one. Now a little bit about the paper class. Right now, in the next class, I will give you the concrete what do you call it? Concrete topics that you can cover. For the time being, I will must show you the all topics are correlated. So even though the chapters are different, but the topics are highly correlated. You can find correlated topics. I'm not giving you the code first. I will not give you the code, and I will not ask for the code. But if you have something, few lines, for example, you can add up as an answer, for example, then there's no harm. But it is not the requirement of the question. So if you found easy to write some sentences of the code, like suppose callbacks, suppose you're asking for, suppose you use the word callback and you want to give the callback early stopping. So you can give by words, or you can give some piece of code. If it's up to you, but it's not preferred to have a code. There must be a better explanation for early stopping. What's the benefit of early stopping? So you can have such kind of things you can have. So it's up to you how the way of writing, what you follow the writing. Now class, I will try my level best. First few questions, one or two question, maybe out of 30, you may have 10 for data science. The first chapters that benefits for the data science, we have some chapters on data science. So I will try to maximum 10 marks. It may be less than the 10 marks for the data science. And rest of the marks you will find on the deep learning and whatever we have learned. So data science topics, the introduction of the data science, you will have 10 marks on it. And afterwards, you will have maybe some reasons. You are supposed to ask some reasons why you split the data in training, validation, and testing. So why you are going to split the data? Then you must have an argument. You must have any answer of this one. Why you want these three parts of the data? Tell why you want normalization of the data before input to the neural networks, or how you can normalize the data while training the model. So recently I taught you the layer. Which layer is there to normalize the data? Anyone else? Anyone there? Recently I
Yes, sir.
explained that. Yes. So you need the normalization in between. Which layer? So go through such kind of text. So there is a layer which is used to normalize your data in between the layers while the training. Usually we normalize the data before input to the neural network. So why we do this? So this is there are reasons in given the slides. So such kind of reasoning can be there. And then you can have maybe a basic structure can be asked for. What will be the basic structure of an LSTM? How it is different from CNN. So such kind of questions can be there. And then some questions on optimizers you have. How you are using, what is the function of basic function of optimizer? And you can go for them. What are the variants of suppose gradient descent? So you can have such kind of questions. Why we want momentum? What's the effect of momentum while we are reducing or increasing or reducing the learning rate? So such kind of reasonings you can have in the examination class. Some about the activation functions. Wow, which one is most popular activation functions nowadays and why? Or what the ReLU function is doing, like we use in CNN, and why we use the sigmoid function or sine function in LSTM. So you can have such kind of maybe 1 mark or 2 mark you are supposed to just justify. Uh, and then machine learning, universal flow of machine learning. Whenever you write a machine learning program, what will be steps you will take? First of all, pre-processing and whatever the steps you have. So this is a universal flow of machine learning. So what is a machine learning flow? Whenever you write any kind of, create any kind of model. And then why RNNs are better than predicting the sequence data and as compared to the CNNs. What's the difference? It means I'm talking about the capability of RNN against CNN. So this is the case you can learn why RNNs are better performed on text data. So there must be some reason over there. So you can go for them. And then tokenization, we have discussed the tokenization, why tokenization word embedding is better than hard-coded tokenizations. So such kind of questions you can have, or simply you can say, give an example of word embedding tokenizations and then explain why it is better than hard-coded. So you are supposed to come up with an example. So such kind of questions you can have. I think I have given the most of the general concepts of question papers. So you will find such of questions. Some are reasoning, some are explanation. So you are supposed to explain with diagrams as I usually do. See here, I'm using so many diagrams here. So you are supposed diagram will support your text. So it's better to be with the diagram. So such kind of questions, you feel it easier, and then I hope you will be able to finish your paper on time. So is there any query, class?
सर वो जो प्रेजेंटेशन थी
Mhm.
फाइनल प्रोजेक्ट की सर वो रिकॉर्ड करके प्रेजेंटेशन भेजनी है या फिर उधर ही
या रिकॉर्डिंग
प्रेजेंटेशन
में
बना
भी
के
मसला
भेजनी
आ
है?
रहा है, मैं मुसलसल मैसेजेस आ रहे हैं मेरे पास, मुसलसल आ रहे हैं उसके अपलोडिंग के ये वो। तो आप फिलहाल ये काम करें,
ओ
आप
सर
रिकॉर्डिंग जिनकी हो सकती है वो कर लें, अदर नहीं हो रही तो फिर मेरे पास कोई चॉइस नहीं है, मैं उनको क्या क्या कहूँ मैं उनको। पर कम से कम ये कि
तो
पीपीटी तो
सर ऐसा करें ना कि
पीपीटी तो हो।
स्क्रिप्ट वगैरह लिख के उससे बजा के।
मैं वही कह रहा हूँ, आप पीपीटी अपलोड करें, बेटर ये होगा कि प्रेजेंटेशन की ग्रुप में है तो फिर मुझे आइडिया नहीं होगा कि क्या हो रहा है आपका ग्रुप में, तो फिर मैं लास्ट क्लास में देखूंगा कि क्या ग्रुप्स हैं क्या है। कम से कम प्रेजेंटेशन तो वहाँ
सही।
हो, कम से कम प्रेजेंटेशन हो वहाँ पे, और मुझे नजर आए कि कुछ कंट्रीब्यूशन है। फिर टेक्स्ट का बहुत वो हो जाएगा, हार्डली चेकिंग होगा कि हाँ उसमें कुछ है या नहीं। मार्क्स फिर दोनों की तकरीबन इक्वल होंगी, मगर ये है कि टेक्स्ट में अगर कुछ
जी
होगा
जी
तो होगा, नहीं तो नुकसान फिर दोनों का होगा, मैं वो नहीं चाह रहा। इसलिए मैंने प्रेजेंटेशन लेना चाह रहा था, और कोई वजह नहीं थी। मे भी बहुत सारी चीजें आप वर्बल बता दें आपने लर्न की हो जो वहाँ हो ही ना, तो ये चीजें बड़ी अनप्रडिक्टेबल होती हैं। ह्यूमन जो है इतना प्रेडिक्टेबल नहीं है बच्चे। सो आई ट्राई माई लेवल बेस्ट टू गिव यू द मैक्सिमम मार्क्स, नॉट द मिनिमम वन।
थैंक यू सर।
हाँ तो वो मुझे कहीं से तो कुछ तो क्लू हो ना, जीरो पे तो नहीं कर
जी
सकता ना,
जी
ब्लैंक पेपर पे तो नहीं हो सकता ना। हाउ कैन डिफरेंशिएट कि ये अच्छा है ये अच्छा है नहीं है, हाउ कैन आई प्रोड्यूस, समथिंग शुड बी देयर। बार बार मैं यही रिपीट कर रहा हूँ कि मेरे
यस
सामने कुछ हो तो मैं मार्क करूँ, नहीं होगा तो मैं कुछ नहीं कर सकता। ठीक है
ठीक है
क्लास,
सर।
एनी अदर क्वेरी?
ठीक है
Hope you will finish your this semester very well and then get the degree very soon. What about the projects? Is there on the way or
सर। सर
uh, is there anyone who found these lectures helpful for their projects? Just raise your hand. I want to see. Is there anyone who found these lectures very helpful to their project work? Some of you I know already. Yes, Ashish. Anyone else? Yes, Mariam. Yes. Yes, Mahanur. Good. Aika. Yes, yes. So you most of the people who are on project are with me. I want to just see. What about the rest? They're the people who are here. They are project based. See, just two, Mohammed Bakar and Waliullah. They are not on the project. I think the same topic. Their topic is different. The rest out of 8, I have 6 participants who have projects in machine learning, deep learning. It means the rest are just for taking it as a theoretical concepts. So it's up to you now. What can I say? I don't say anything. So class, I'm going to. Is there any query or any question you can ask right now? Inshallah, on Thursday, we will have a face-to-face class for further queries. So you come up with the queries if you have any. For today, I think I have finished most of the things. So if there's no class on Thursday, I don't think so there will be any problem. I have cleared each and everything by today. For the safe side, I made this one. Maybe next class, what will happen, highly unpredictable. So if you are here, then I will conduct the class. If someone is not here, so you can pass the comments with each other. You are listening me very well. Yeah. So any query class, you can just raise your just hands down. So can I stop the lesson, today's lesson class and the session, because I have finished everything by
यस सर।
today. Okay. See you on Thursday.
Thank you, sir.
Assalamu alaikum.
थैंक यू सर।
Assalamu alaikum.